We're in 6.3 and we are graphing a line using intercepts. In this example, we are determining the x and y intercepts and then using them to graph the line. We're going to use them to graph the line. So we know the definition of x and y intercepts. So the x and y intercepts, we know that definition. We've been working with that for a little while now. So the x and y intercepts, and we are going to use those to graph the line. So when we do this, first of all, the first step would be, I need to find the x and the y intercepts because I don't have those. So step number 1, let's find the x and the y intercepts. I'm going to title it, like I said, so I want it x intercept is when y equals 0. And I'm going to do my y intercept, which is when x equals 0. So again, always write a title. We do not want to just start a bunch of calculations. Okay. So x-intercept is when y equals 0. That means that we are going to sub in 0 wherever I see the y. All right, sorry. Wherever I see the y. So take this equation. I have one equation, and we're going to do this. So we're going to go 8x minus 4, 0 minus 16 equals 0. So you'll see here, my y equals 0 meant I subbed in 0 in for the y. And we're going to, 4 times 0, that becomes a 0. Right? 4 times 0, that becomes a 0. We've got 8. You're going to rewrite everything that's left over. 8x minus 16 equals 0. That's gone because I put 0 in for y. So make sure I'm doing that right. Then when I'm solving this, I'm going to bring the 16 over to the other side. I'm going to make it positive 16. So 8x equals 16 when it hops over the equal sign. When you want to get rid of the number in front, we divide both sides by the 8. And we're going to go x equals 2. So that, therefore, this gives me 2, 0 as a coordinate. And then you can even plot that point. That'll be 2, 0 right here. Some people say, do I have to write as a coordinate? You don't have to. I like to do it just because it helps me out in a lot of situations. Right, so I think of that as a coordinate. I do like to write that. Then my next step over here, we're going to do the same thing over here. And I'm going to put wherever I see x, I'm going to sub in 0. So 8, 0 minus 4y minus 16 equals 0. So look, this here meant I subbed in 0 here. Wherever I see x, I subbed in 0. That cancels out to be 0, 8 times 0, and I write down what's left over. Make sure you don't drop this negative. A lot of times people drop the negative, okay, you're going to lose a mark. Anytime you lose a negative, you're losing a mark. Right, it's a full mark now. You should not be dropping negative. So this one here, make sure you carry the negative 4y here. Bring the 16 over. You don't have to show the arrow. I'm just showing you what I'm doing in my mind. So 4y equals 16. And then look, so this is important. Again, a lot of people drop this negative. When you divide both sides, you're dividing both sides by negative 4. Okay, and you lose a full mark every time you're losing negatives now. Right? You can't keep dropping the same negatives anymore. So y equals 16 divided by negative 4 is negative 4. That gives me the coordinate 0, negative 4, which is 0, negative 4. So if you got positive 4, it's because you dropped the negative. Right? So make sure you follow that negative. So right, this becomes 0, but you have the negative here, follows down here, divide by the negative, and you get a negative 4. It'll change your graph whenever you drop a negative. So when it says determine the x and the y intercepts, which is what I did here, and use them to graph the line, that means I'm going to take these 2 points, only those 2 points, plot them here, which I just did, and only do this. So I know that there's no step pattern, but the instruction said specifically that I just want you to use these 2 coordinates. So look, determine the x and y intercepts, which we did. Use them to graph the line. So use these 2 to graph the line. Make sure that's all I need. I don't need any more. Make sure you put arrows on the end. Right? I want arrows on the end, and you have to use a ruler. So arrows and a ruler. Right? and I want it long. So even though it's only got these two dots, I don't want a tiny little graph. I want you to make it longer so it finishes up the area. So I want you to extend it for the whole graph. So you know it's only those 2 points, but I still want it longer. Okay, so even though it's only those 2 points, make it longer with the arrows and the ruler. Let's try that again. Okay, so again, you've got this pattern. Let's try it again. So I want x-intercept, y-intercept, and use that to graph. So x-intercept is when y equals 0. My y-intercept, you'll see I'm just titling it. Like, it's not a lot of work. I don't want a ton of titles. I don't need you doing a ton of work here, but I do need you to organize your answer. It is part of your communication. So take this equation. It can be in any form. It can be mixed up. So I know this is kind of a messy form. It's not y equals mx plus b. We're still subbing it. So we're going to go 3x plus 0 equals 6. So wherever I see the y, I subbed in 0. So that's what I did here. 0 times anything is 0, so that's just gone. Right, so it's just gone by itself. So I write down what's left over. 3x equals 6. Divide both sides by the 3. I'm going a little faster now because I'm hoping that the solving part is getting easier. That becomes a 1, so x equals 2. So therefore, it's 2, 0. You can plot that right away if you want, 2, 0. So that's 1 point. The y-intercept, you're going to take the same equation, 3, and wherever I see x, you're plugging in, subbing in 0. Right, so this 0 here goes in for the x is 0. That goes away, going a little bit faster now, I'm hoping that you're following. Y equals 6. There's nothing else to do, so then I know it's just going to be 0, 6, which will be 0, 6, which is up here, 0, 6, and that's it. And so I only want you to use those 2 points. So in the instructions it says use those 2 points to graph. I don't need you to use the step pattern. We're just going to go ahead and graph these, make it as long as possible. Arrows on the end, ruler, we're good to go. But don't make it really short. So I know we're only using those points, but I still want you to make it a long line. Ruler, arrows. And do this again. So hopefully it's getting nice and repetitive, right? And that just means that you're getting the hang of it and you've got the concept in your head, which is amazing, which is x equals 0. So again, wherever you see y, you're subbing in 0. So x minus 5, 0 equals 5. Wherever you see y, cross that off, write down what's left over, and I don't have to do anything else, so it's 5, 0. And you go, wow, that's not bad. And then here, wherever you see x, you're subbing in 0. So I'm just giving you different scenarios where I'm subbing it in. Whoops, right. That's a 5. So I subbed it in, but there's nothing to cross multiply with, so I just cross it off. It's just 0. You don't have to cross it off, but in your head you're thinking, oh, it's the same as this, so I rewrite it without the 0. And then if I have a negative in front, you divide both sides by exactly what's in the front. So it's -1, so then it's 0, -1. So you have 0, -1, which is here, and you have 5, 0, which is here, and then you have a really almost horizontalish line, and that's okay. You're just going to still do this and going to make it as long as possible, so not short, with arrows on the end. So long, long, arrows, and ruler. Okay, want it long, arrows, and ruler. So long means like fill the grid, arrows on the end to say it keeps going, and use a ruler. Okay, so long, arrows, and ruler. That's what I wrote there. And we're going to try the next page. I'm going to do that a few more times. So for this one, same idea. We're going to do x-intercept is when y equals 0. Y-intercept is when x equals 0, like that. And when we sub this in, we're going to sub in 0 for y. Oh, so now I gave you a new case. So you're thinking, why am I doing so many examples? Just so that I cover kind of all the cases. If I don't have a y to sub in, I just don't sub it in anywhere. So I just rewrite the equation like this and say, well, I would sub in 0 if I had a y, but look, there isn't a y. So I can't sub it in. Then I just solve this one, and I go 4, 4, and I cross that off. It's 1, so x equals 6. Then, if I try to get my y-intercept, so I know x is 6, which will be here, so plot that point. If I try to get my y-intercept, I go, well, x equals 0, so it'll be 4, 0 equals 24. I cross that off, it becomes a 0. And then you go, wait, I have nothing on the left side, so I get 0. That makes no sense. So this one here is no solution. This says no. That is no solution. This makes no sense. 0 is 24. That's nonsense. The reason why it's nonsense is because, look, see, this is a special case. So this is a special case. That's when x equals 4x equals 24. This is x equals 6 all the time. There is no other point because it's a vertical line. And when you look at this equation, so as long as possible with arrows, if you look at the equation, this is just x equals 24. So if I took this equation and divided by 4, you would get x equals 6. So you go, wait, that is a special case because it's only x equals a number. So that's why it gets me a 6 and only a 6 and nothing else. So that is tricky. We're going to double star that because when you go to find the other intercept, it doesn't work. And look, you'll notice it because it's 4x equals, it's a different sort of equation. Look at this one. Do you see how that's also the same? These are both different equations. So this is 4x equals a number. This is 2y equals a number. There's no x and y. So when you try to do this one, if I go x, so look what happens here. X-intercept is when y equals 0. And then y-intercept is when x equals 0. So as soon as you see that it's a special case, so as soon as I saw this, you didn't have to say that there was no solution. Or you could say none, right? So no y-intercept is none, right? So therefore, no y-intercept, conclude that. And then here, when I go for the x-intercept, I try to put in y equals 0. So I'm going to go 2, 0 equals negative 6. Cross that off, it gets 0. You get 0 is negative 6. So this is no solution. That's short form for solution. If you go SOL-N, that's solution. No solution. And then you'd say, therefore, no x-intercept. Right? So none. Or x-intercept none. Right? So same thing. And then here, when you plug in x equals 0, you're going to go 2y equals negative 6. There's nowhere to put 0, so you just rewrite it as is. Divide both sides by 2, and you're going to get y is negative 3. So my y-intercept, so therefore it's going to be 0, negative 3. This one up here, sorry, I forgot to conclude it, is 6, 0. Right, and no y-intercept. So this is no x-intercept, and the y-intercept is negative 3. So one more time. Look at this equation. It's 4x equals a number. There's no x and y, so it's a special case. That's why one of them gets no solution. Here, we have 2y equals a number. There's no x and y, so that's why when you look for the other one, you're going to get no solution for the x-intercept. When you go to plot this, it's 0, negative 3, which is here, and nothing else. And it has no x-intercept, so that's the case where it has a y value with no x value, so it's a horizontal line. You'll get used to the horizontal and vertical lines. They are special cases. They're hard to get used to at the beginning, but that's what happens. So when you see this type of equation, it's y with no x, it's going to be this horizontal line. Here we have x with no y, it's going to be a vertical line. And you'll get used to getting no solution on one because you already knew when you saw this equation it was a special case. And you're like, oh, I know it's one of the special cases, so I got the y, but I didn't get an x. Okay, and those special cases are a bit strange to work with, but that's why I'm calling them special cases. But once you get used to them, they're pretty straightforward, but you have to get used to them first.